All right, folks, how we doing today? We're going to be talking about derivatives. And let me get myself situated here. So the first problem we're looking at here is a pretty typical one. They give us an equation of a curve, and what they want us to do is they want us to find the equation of the normal to the curve at this particular point. Now keep in mind, a normal line is a perpendicular line. And this is a really good clue that what we're talking about is a derivative. Derivatives are used to find slopes. And so basically, we need to find the slope at this point. And the first step is going to be to find this derivative. So let's go ahead and try that. So I'm going to write this equation again. Y equals to square root 3x plus 4 and then minus x. All right, so keep in mind, we've got two basic rules that we've got to worry about, and that's the power rule and the chain rule. And you'll notice that in this case, they're going to use both of them. So we're going to take this problem and we're going to rewrite it so we've got some powers here. So this is going to be 2 times 3x plus 4 to the 1/2 power. And this is still going to be minus x. All right, so what I'm going to do is I'm going to do this in parts. When I want to find the derivative, I'm going to tell people I'm doing the derivative. That's dy over dx. And keep in mind, basically, when you're doing a derivative, what's going to happen is that you're going to multiply by the exponent and then subtract 1 from the exponent. So basically, we're going to take 1/2 times 2, and in this case, I'm going to write it out. 1/2 times 2 over 1, and then this is not going to change. And now, what I'm going to do is I'm going to also multiply it times, well, I'm going to go ahead and I'm going to subtract from this, so this becomes negative 1/2. And then I'm going to multiply it by the derivative of the inside. I've just taken the derivative of the outside. Now I'm going to take the derivative of the inside. And so the derivative of the inside, 3x plus 4, is just going to be 3. So I'm going to multiply this whole thing by 3. Now, that's this. I just found the derivative of that. Now I'm going to find the derivative of this. And see, keep in mind, this is going to be 1 times negative 1 2x, and then it'll become to the 0 power. So this is going to end up being minus 1. And so now when I go ahead and I multiply all this together, well, 2 times 1/2 is going to be 1, and then 1 times 3. So now I've got 3x plus 4, all to the negative 1/2 minus 1. Now, we could go ahead and fix this so it doesn't have a negative exponent, but as far as answering the question in part A, this is perfectly fine because our calculator can deal with exponents that have negative powers. So keep in mind, what's going to happen is we're going to take the derivative and we're going to input the x value of the point where we want to find the slope. So keep in mind, what's happening is when we've got a curve, basically we've got a curve. Well, depending on the point, there could be different slopes. And so I want the slope at this one particular point. And so all I got to do is input the x. And so this is going to be 3 times 3 times 4 plus 4 to the negative 1/2 minus 1. And all you've got to do is type that in your calculator. I'll pause this for a second and go ahead and find the answer. Pause it and then start back up again when you're ready. Okay, so hopefully you did that, and you'll find out that the slope at this point is going to be negative 1/4. Now keep in mind, our slope is going to be perpendicular to this tangent line. What we've just found is the slope of the tangent line to the curve at the point 4,4. And so now what I've got to do is I've got to change this slope so it's a perpendicular slope, which is you multiply by -1 and then flip it or take the reciprocal. So the perpendicular slope is going to be 4. And again, I can write the equation of any line when I have a point and a slope. And I can put it in point slope form or slope intercept form. I'm just going to put it in slope intercept form. So what I'm going to do is I'm going to input the x and the y from the point and the slope, and I'm going to find out what my b is. And I get 4 is equal to 4 times 4 plus b. So this is going to be 4 equals 16. And when I subtract 16 on both sides, b is going to equal -12. And so the equation is going to be y equals 4x minus 12. This is the answer to part A. This is the form. And then notice here they were specific about not putting it in point slope form. They wanted it in y equals mx plus b, so we didn't really have a choice in that case. All right, so there you go. That's part A. Okay, so now let's take a look at part B. In part B, they want us to find the stationary point. Now, in this case, what's happening is they're actually giving us the slope, and then we're going to work it backwards and find the x value. And so keep in mind, when I've got a stationary point, it could be a maximum or a minimum. And at either one of those points, the tangent line is going to be a horizontal line. So it's going to have a slope of 0. So when they ask you for a stationary point, they're basically telling you that the slope is going to be 0. So let's go ahead and rewrite this derivative. It looks like this. dy over dx is equal to 3 times 3x plus 4 to the -1/2 minus 1. All right, so in this case, probably what I'm going to do is I am going to make this equal to 0. And then I'm probably going to rewrite this so it doesn't have this negative exponent. So that's going to give me 3 over the square root of 3x plus 4, because the negative exponent is going to go in the denominator, and 1/2 is a square root, and then minus 1. All right, so what I want you to do is I want you to go ahead and pause this and see if you can't get that x by itself, and then start back up again and we'll see how you did. All right, so hopefully you did that. So what we've got here then is I'm going to go ahead and add 1 to both sides. And then I'm going to multiply both sides by square root of 3x plus 4. And that's going to give me the square root of 3x plus 4 is equal to 3. And now what I'm going to do is I'm going to square both of these sides. And that's going to give me 3x plus 4 is equal to 9. And when I subtract 4 and divide by 3, x is going to equal 5/3. Now, keep in mind, that is the x part of my stationary point. If I want to find the y part, and I do, because you notice they asked me specifically for the coordinates, then what I'm going to do is I've got to take the 5/3. I'm going to take the original equation, because remember, derivatives, you put in x's and they give you slopes. Equations or functions, you put in x values and you get out y values. And so what I'm going to do is I'm going to write this y equals 2 times 3 square root of 3x plus 4 minus x. And see, now all I've got to do, and again, if I were you, I would just use the stow function of my calculator and stow 5/3, but basically it looks like this. Minus 5/3. And see, this is going to end up being 5. because 3 times 5/3 is going to be 5. 5 plus 4 is going to be 9. Square root of 9 is going to be 3. This is going to end up being 6 minus 5/3, and that'll be 13/3. Okay, so keep in mind, derivatives are used to find slopes, but it's also possible that they'll give you a slope, and you have to work it backwards and find the x value. But also remember that that's all a derivative can do. And so you've got to, if you need to find the y value, then you need to go ahead and plug that back into the original. All right, so let's take a look at number 2 here. Oh no, let's not. Let's take a look at the key here, the rubric. All right, so you'll notice here, finding the derivative correctly, and if you make one error, you can get 1 point. If you get the whole thing right, then you get 2 points. And the common error, honestly, is to forget about this minus x and leave it off. But this is not too bad for 2 points, okay? Now, the method here is substituting in the x value of 4 into the differential equation. So even if your derivative is not actually correct, but you substitute your x equals 4 in there, then you can get this point. All right? Now, you'll come up with a slope. And then what you've got to do is you've got to find the perpendicular slope. Now again, even if you do this and get the wrong slope and the wrong perpendicular slope, you can still get this method point. And then if you plug in for the point 4, 4, using your slope and come up with a line, you can get this method point. But then to get the whole thing correct, you actually have to use this right, get the right answer. All right, so, I mean, number 1, you can get the derivative partly right and get 1 point. You can do a method point and do the right thing. You could get 3 out of these 5 points and have things screwed up. But on the other hand, I want you to understand that in a multi-step problem like this, if you make a mistake in the first step, then it's going to be impossible for you to get everything right. So it really is important that in these early stages of the problem that you're really being careful and that you're not making mistakes. All right, so now in part B, you'll notice that we've got the derivative and we made it equal to 0. That's just the method point. Okay, so that just doing that and then trying to solve it is going to get you 1 method point. And then solving as far as getting x by itself, and that is going to get you a method point. Doesn't even have to be right. And then once you get the point or you get the actual thing, you need to have both of these by plugging it back in and get the points for the 3. All right, so that's 8 points altogether. This first part, this 5, is not really super tough, so that's very, very doable. All right, let's take a look here at the next one. Oops, that's the same question, right? No, this is different. Oh, it's not different. So, this is the same question. This is part C and D. Oh, there you go. I just spread it out because it was taking up too much room. All right, so in here, we found C. Oh, no, we found the stationary point, right? Okay, I get it now. And now they want to determine the nature of the stationary point. So keep in mind, first derivatives, they're used to find the slope of tangent lines. And then second derivatives are used to find the nature, and the nature meaning of a stationary point is whether it's a maximum or a minimum. So in this case, let's go ahead and get some of our stuff caught up. Our derivative was equal 3 times 3x plus 4 to the negative 1/2. And then minus 1. That was our derivative. Now, to find a second derivative, all you do is find the derivative of the derivative. So again, I'm going to start by multiplying negative 1/2 times 3. That's going to, well, here I'm just going to write it. So negative 1/2 times 3 over 1. And then I'm writing this down. This part doesn't change. This is going to become, I'm going to reduce it by 1, so it becomes negative 3 halves. And then I'm going to multiply by the derivative on the inside. And so that's going to be a 3. I'm just going to go ahead and put that over here. Because I happen to have room. Now, the derivative of negative 1. Keep in mind, the derivative of a constant is always 0. So I'm going to put plus 0, but it doesn't make a difference. Okay? So anyway, 3 times 3 is 9. 9 times negative 1/2 is negative 4.5. So I got negative 4.5 times 3x plus 4 to the negative 3 halves. And again, this is a second derivative. The notation for this is going to be d2y and then dx2. This tells people that they're looking at the second derivative. All right? Now, keep in mind, it works pretty much the same way. My stationary point was 5, 3, comma, 13, 3. All right. The stationary point, to find the nature of a stationary point, take the x value and put it into the second derivative. So this is going to be negative 4.5 times 3 times 5/3 plus 4 to the negative 3 halves. And like I said, your calculator can handle the negative exponents just fine. So I would just go ahead and type this in. Do me a favor, pause this, type that in, and see if you can figure out what this is equal to. And then start back up again when you're ready. Okay, awesome. Hopefully you did that, and if you did, you found out that this is going to equal negative 1/6. Now, we don't care what the number is. All we care about is whether it's negative. If it's negative, then the stationary point is a maximum. Basically, think of it like this. I plug in the x value into my second derivative, and it's going to tell me what's going to happen immediately after. So, if immediately after the slope is going to be negative, well, that means it must be a maximum. Okay? If the slope immediately after my point is positive, that means it must be a minimum. So, we now know the stationary, or the nature of our stationary point. That's part C. And then in part D, it says find the exact area of the region bounded by the lines x equals 0 and x equals 4. All right, now I know that I'm supposed to be talking about derivatives today, but in order to do this last part, this part D, we're going to use integration. So what I'm going to do is I'm going to kind of switch gears here, and it's not implausible that they could do something like this, and you've got to make sure that you're okay with what's going on, because you'll notice in none of this problem did it say use derivatives or find second derivatives, and here it's not even saying to integrate. So you need to know, what these functions are. So basically, the reason I want to go ahead and do this, even though I'm talking about derivatives today, is to kind of drive point the difference between integrating and finding derivatives. When we do derivatives, we multiply times the exponent, and then we subtract 1 from the exponent. I mean, simply put, but yeah, that's basically what it is with our rules. And see, what we're going to do with integration is we're going to add and then divide. So here I'm going to go ahead and write this derivative again, or my equation of duh. And we're just going to copy it from up here. Y equals 2. Now here I'm going to go ahead and bring the powers back. 3x plus 4 to the 1/2, and then minus x. Okay, so what we're going to do is we're going to take this curve, and then what we're going to do is we're going to integrate it, and then we're going to use these boundaries of x equals 0 and 4. So let's go ahead and start that. Basically, I'm going to write this, because remember, what I'm going to do now is I'm not going to multiply and then subtract. What I'm going to do is I'm going to add. So I'm going to start by writing this base, and then I'm going to make it 3/2. But then I'm going to divide by this, which is the same thing as multiplying by its reciprocal. So I'm going to do times 2/3. Okay? All right? Now, I'm also going to multiply by I'm going to divide by this 3, which is multiplying by its reciprocal. Okay? Now, here I go over here to the x to the first, and see, I'm going to write the x. It's going to become a power of 2, and then I'm going to multiply by its reciprocal, or divide by 2. This is going to become negative 1/2. All right, so all I got to do now is multiply this stuff together. This is going to end up being 4/9, right? 4 over 9. And then minus. All right, so what happens is this, if you will, is our integration function. And what we're going to do is we're going to put in both values. We're going to put in the 4 and the 0. And then we're going to subtract them. And I want you to go ahead and pause this. Input a 4 for all these x's, and then get a value. And input a 0 for all these x's, and then get a value. And then let's subtract them and see what we get. I'll pause it and then start back up again when you're ready. Okay, so hopefully you did that. If you did, here's what I got. I ended up getting 184 over 9. And then I got 32 over 9. And then that equals 152 over 9. This is going to be the area underneath this curve. And I'm going to leave it just like that. Okay, so let's take a look at the rubric. Again, you'll notice, find the second derivative. We end up with negative, well, they use 9/2, but that's the same thing as negative 4.5. And then again, this part's on, it doesn't have to be exactly like theirs. But here you'll notice it's a method point. You're trying to get the second derivative. So even if it isn't exactly perfect, then you can still get a method point for this. And then, of course, finding that this is negative, so it's a maximum, that's going to give you the second point. All right, awesome. Oh, and I didn't put the integration thing on there because, quite honestly, I wasn't sure that I was going to do it. I was going to skip it, but I decided to go ahead and do it. So anyway, like I said, integration, what happens is that it's adding to the exponent and then dividing, but you'll notice that especially when we're talking about fractions, we end up multiplying by the reciprocal, and so that's where some people get confused. But you have to be really clear about what it's like to find a derivative and what it's like to find it to integrate, because it's very easy to get them mixed up while you're doing them. Anyway, that's it for that. Let's take a look at the next one. And quite honestly, this is a kind of a different kind of a problem. And if people saw this on the first time for the test, I bet you they were confused. But in any case, it's very likely that you may see a problem on the exam in the spring that you've never seen before and it doesn't make any sense to you. And what I want to tell you is that you should be trying to think about what it is they're talking about. But, I mean, if you just follow their directions and do what they say, a lot of times you will be fine, even if you're not really sure why you're doing what you're doing. So, in this part here, you'll notice it says we've got this equation, and granted, this is a pretty weird equation, but it looks like this, okay? And then we've got these points on the curve, okay? Here's a point A, and then B, and see, you'll notice this pattern here. What happens is that it goes from 2 to 2.9, and then it goes to 2.99, and then 2.9999, and it goes to 3. So it seems, painfully gradual as we get closer to this number 3, but you'll also notice that the slope is going to go in this way. All right, so we're not really sure what's going on, but let's just see what it says. It says find K, give your answer correct to the 4 decimal places. Okay, so, I mean, these are points that came from this function. So that means what you've got to do is plug in the x values into this function and find out what k is. So pause this and try to do that, and then start back up again when you're ready. Okay, so hopefully you did that, and if you did, you substituted in the 2 for the x, and then hopefully you just type this, and you should have gotten that y was equal to 1.2679. Now keep in mind, y is k, but that's what they asked us to find. That's part A. That's worth 1 point. It wasn't that hard. Who knows why we did it, but we did it, and that's fine. So now, part B. Find the gradient of AE. Okay, so that's asking you to find the slope, right? And so to find the slope, I'm going to do y2 minus y1 over x2 minus x1. And again, you'll notice I just have 2 points. I happen to have this point now is A is 1.2679. Again, make sure you're clear. They said go 4 decimal places. 1, 2, 3, 4. All right. So they're just asking us to find the slope. So pause this and find the slope of these 2 points. Subtract the y's over subtract the x's. Pause it and start back up again. Okay, so hopefully you did that, and I do 3 minus 1.2679, and then it's going to be over 3 minus 2. So 3 minus 2 is going to be 1, so this is going to be 3 minus 1.2. I'm going to get the slope of 1.7321. All right, that's again only one point, but it wasn't that hard. And even if I still don't know what it is we're doing or why we're doing it, that's what's going on there. Okay, now here what I want to explain something about this third part. It says the gradients, the slopes of BE. So that means this point and this point, BE, and then CE, and then DE. Rounded to the 4 decimal places are these numbers here. 1, 2, 3. So let's kind of give you kind of an illustration. Imagine here we've got a curve. And again, I don't know where things are. So let's just say that E's up here. Okay? And we're going to say that A is down here. And then B, you'll notice B went from 2 and then almost to 3. So here we're going to say this is B. And then we're going to say this is C. And then this is D. Okay? So basically what they're saying here is, and again, you just found this slope, AE. You just found the slope AE. So you notice it's 1.7, all right? So if I were to take a line, let's see if I can do that. A line, okay. And I were to find this slope here. Whoops, that's a little bit bad. Let's try that again. If I were to find the slope between these two lines, that's better. Okay, we just figured that out. That's 1.7321. And see, now what they're saying is that if I find the slope BE, which BE is going to be the slope from these two lines, okay, it's 1.9748. And then it says the point CE, which is the slope between these two lines, is 1.9975. And then it says the slope between DE, which again is closer and closer, and it looks like this, it's 1.997. Now what they want to know is, based on this slope is 1.7, this slope is 1.9. Oops, I can't write with that. 1.97, and then 1.99. Do you see? It's getting closer and closer. Now, they want to know what I would guess is the slope of the point or the curve. No. What's the slope at the point E? So again, that's this. Whoops. Here, make it so you can see it. That's a tangent line. Okay? Now, you'll notice that it's pretty close to what DE is. All right? So what's happening is, you'll notice as I get closer and closer and closer to this point, I get a smaller and smaller distance. The slope becomes closer and closer to a certain number. That number would appear to be 2. All right? It seems like the slopes are approaching 2. I would expect the slope at 3, at point E to be 2. Okay? Now, this is using the concept of limits, which quite honestly is not really in this curriculum, and so I'm kind of surprised to see this question here. But this is kind of goes to this premise of what it is to be a derivative. A derivative is the slope of a line at one point, and instead of finding these various slopes or finding slopes that are really close together, we've used this formula. Anyway, that's how that one goes. And you can see here, first 1.2679. I mean, there's no method. They expect you to be able to do this. All right, now you'll notice, hopefully you got 3 minus square root of 3. It said specifically to give your answer in 4 decimal places. So if you write 3 minus square root of 3, you're not getting anything. And then it says to find the slope, and we got 1.7321. Again, that's another 1 point, pretty easy. And again, here for this next part, they're basically seeing this 2. All right, so notice how if they see this 2, or in reference to the slope, they're going to give you this point. Okay? Now, the next point is the slope of E is the limit. And again, as it gets closer and closer, but if you wrote the words approach, which you can see that pattern there, clearly the slopes are getting closer and closer to the number 2. then you could get that second point. All right. So anyway, I thought that was a little bit different. So here's what I want you to do. Take a look at this one. It says they're giving you a derivative, and they're giving you this k as constant, and they say the curve has a stationary point at 2, -3, 5. And they want you to find the value of k. So again, keep in mind this whole notion of stationary points. Stationary points are where the derivative equals 0. Okay? So we can use this, and they've given us the derivative already. I'm going to write it down. Part A. It's going to be the derivative all right, so they're saying that the gradient of the curve is where k, okay, so the curve is given by this derivative. Okay, so there's our derivative. We're using this derivative to find the gradient, the slope of this curve. K is a constant, some number, and the curve has a stationary point at 2, -3, 5. Okay, so basically they're not asking. So if I had this k, if I knew what k was, it's possible they could say find me the stationary point. Instead, in this case, they're saying here's the stationary point and find k. So what I can do is make this equal to 0. And then substitute in, for all these x's, a 2. And so you notice now I've got an equation that only has one variable, k, and I can find the value of k. Pause it and try finding the value of k and start back up again when you're ready. Okay, so hopefully you did that. And if you did, you found out that k is equal to 3/2 or 1.5, right? Okay, shouldn't have been that hard, but hopefully you were able to do that. Now, in part B, it says find the equation of the curve. Now, once again, this is going to involve integration, and we might as well go ahead and do it. So if I'm given a derivative, then what I can be asked to do is return it to its former self. They call it an antiderivative. It's the original equation. All right. Now, the problem is that you remember that when we do a derivative of a constant, it's always 0. So we won't ever be able to find the whole exact equation. I'm going to go ahead and put the k that we found in place. So it's going to be 3/2 x squared. All right. Now, what we're going to do here is we're going to integrate this. Okay, we found k, so now this is complete. And what we're going to do is we're going to integrate this, and what we're going to do is we're going to add and then divide. So I'm going to start by writing the base because it's not going to change. And see, now this is going to become a 4, and then I'm going to multiply by 1/4, and this 6 is still here, but I'm going to make it 6/1. So I'm going to multiply by 1/4. Okay, and then I'm also going to divide by 3, which is the same thing as multiplying by 1/3. Okay, so that is me integrating this, right? And now I'm going to integrate this. So I'm going to write x. I'm going to add 1 to the exponent. And see, now what I'm going to do is I'm going to multiply by 1/3. That's the same thing as dividing by 3. So here, let's just write it. Minus 3/2 times 1/3. Squeeze it in there, right? Okay. And go ahead and pause this and see if you can clean this up for me. And then start back up again when you're ready. All right, so hopefully you did that, and if you did, hopefully you found out that this is all going to end up being 1/2, and then 3x minus 5 to the 4th, and then this is going to end up being, again, 1/2. Notice how these 3's cancel out, so it'll be minus 1/2 x to the 3rd. Okay, now, that's the thing. Y equals, I'm starting to make my original equation, but keep in mind, there could always be some number that if I would have taken the derivative, I never would have taken the derivative of it. So whenever you're finding an antiderivative, whenever you're taking a derivative and trying to go backwards, it's called an indefinite integral, and we have to have a plus c at the end, okay? And the way we find what its actual value, this value of c is we take the point that we know is actually on this curve, and we've substituted in for x and y, and then we find out what c is. So do me a favor and substitute in a 2 for all the x's and a negative 3.5 for the y, and solve it for c, and then tell me what you get. Pause it and start back up again when you're ready. Okay, so hopefully you did that, and if you did substitute all that in, you should have found out that c is equal to 0, because this is going to be negative 3.5 equals 1/2 3 times 2, which is 6, and the 6 minus 5 is going to be 1 to the 4th, and then this is going to be 2, we'll put in there 2, so that's going to be 8, so it's going to be minus 4 plus c, and so you can see how this is going to end up being negative 3/2, right, this is going to be 1/2, 1 to the 4th times 1/2 is going to be 1/2, 1/2 minus 4, so that's going to be negative 3.5 is equal to negative 3.5. And so then when I add 3.5 on both sides, I find out that c is equal to 0. And so this is going to be the answer. It doesn't have a constant. But you always got to check. Quite honestly, most of the time there will be one. Okay, there is the original equation. So what we're doing is we're taking the derivative, we're trying to put it back to where it was. Keep in mind, we can never do that by just using an integration. What we can do is we can get really close, but we can't get the constant on the end, so we have to put a plus c until we figure that out. And the way we figure that out is by using a point that hopefully they gave us. All right, so let's take a look at here. In part A, find the stationary point. We made it equal to 0. And here you can see, look, take a look at what they're looking at here. 6, and then the k here. 6 times 3 times 2 times negative 5, and then we end up with equaling 0. So this is a method point. Basically what they're doing is you put in the x's and make it equal to 0. You should find out that k is equal to 3.5 or 1.5. OE means or equivalent. It doesn't have to be a fraction. All right, so here's the method. Make it equal to 0 and substitute in the x. If you do that somehow, and even if you screw it up, you can still get that method point. And then getting it correct is going to get you the other point, 1 point. Okay? And see here now we're doing an integration, 4 times 3, 6 over 12, and see, it doesn't have to be written exactly like this, but you can see that's what we did here. And again, the plus C is very important. But here we got this method point, and then getting it absolutely correct is going to be here. So integrating and increasing the power by 1 in at least one term. Okay, so making some attempt to integrate this is going to get you a method point. You have to show some kind of, by adding an exponent, they're realizing you're not doing the derivative. And then if you follow through, so say for example you integrate incorrectly, but you get something like this, you can get this point. The follow through is from the K. Say for example you screwed up and you got the wrong K, then you could still get this A1 point if whatever your K is still over here. All right, and so then again, it's dependent on this previous thing, but again, there's a method point. Using the point 2, negative 3.5 into the integrated expression with the plus C, that's again the method. Okay, so that's what we do. And then they need to see this answer. The answer is that, there's nothing at the end. It just looks like this. All right, hopefully that made sense. Let's take a look at this one. In number 3, it says the gradient of the curve is given by this derivative, and the curve has a stationary point. Oh, wait a minute. Now, so I'm sorry. We're still in the same question. This is part C and D. All right, so this whole thing, you notice how they're doing some integration and derivative. This whole thing is worth, let's see, this is worth 4 points, and that's worth 6 points. So this whole problem is worth 10 points, A, B, C, and D. All right? And what they've done is they've taken integration and derivatives and put them in the same problem. All right, so again, very common thing. What they want us to do is they want us to be able to find the second derivative. So do that, pause this, and you see where it says the derivative here. Oh, and remember we had the K, so let's go ahead. We have our derivative. K we found was negative 3 halves or 3 halves. All right, so there's our derivative. Now what they want you to do is find the second derivative and then determine the nature of the stationary point. This is a very common thing. So pause this, see if you can find the second derivative, just like we did before, and then substitute in the value of 2 into your second derivative and tell me whether or not it's a maximum or a minimum. Then start back up again when you're ready. Okay, so hopefully you did that. If we do the second derivative here, what's going to happen is that we are going to keep this. We're going to multiply 3 times 6, and we're going to get 18. 3x minus 5. This is going to be to the second power. But then we're going to multiply by 3. And then this is going to be 2 times negative 3 halves. So that's going to be negative 3. And then it'll be x because I take away 1 from that, right? And so 3 times 18 is going to be 54. Minus 5 to the second minus 3x. And if I substitute in a 2, I'll find out, or I'll get the answer 48. And that's 48. That means that that at x equals 2, the stationary point is going to be a minimum because it's positive. So that means immediately after that stationary point, it's going to go up. This must be a minimum. All right, so there you go. There's that. And so let's take a look at those two. Again, you can see here we're doing the second derivative, 3 times 18, negative 2, and then again, you'll notice that if you're still using the wrong k throughout this whole problem, you can still get this point. And then if I plug in the 2, I get a 48, which then I say because, and again, you've got to make some kind of statement that it's a minimum. You can't just say, oh, it's 48, and then stop. Okay? All right, awesome. Take a look at number 4 here. It says that I've got this function. Now, this is a function, and it is for 1/2 to a. So the x is, that's the domain they're giving me right there. And what they're talking about is they're talking about it being decreasing. Okay? So what basically I need to know is what's the a value where it's negative, right? So let's go ahead and do that. This is a function, and keep in mind that derivatives find slopes of tangent lines. And for example, if I have this curve here, all right, the slope on this side is going to be positive. That would also let me know that it's increasing on this side. The slope on this side is going to be negative. That would let me know it's decreasing on this side. So, it's again another reference to slopes. And so I'm going to have to find the derivative. And the notation here we'll use is f prime. And we're going to start by multiplying 3/2 times 1/3, and we'll just write it out. 3/2, 1/3, and then I'm also going to multiply it by the derivative of the inside. So that's going to be 2/1. This is going to be 2x minus 1, and then I take away, so this is going to be 1/2. And again, you got to be careful, because you'll notice we have two situations here. I've got to find the derivative using a chain rule, and then I got to find the derivative of just a power thing, and it's a pretty simple one, but you'd be amazed how many people forget about this last part. So what I'm going to do here is I'm going to take the 1 and multiply it times -2, and then subtract the power, so it ends up being -2 times x to the 0 power. That's going to be 1. Just keep in mind, whenever you find a derivative, it's going to be some number x. It's always just going to be that number. So this is going to be -2. All right, so that's our derivative, and we can clean this up a little bit. You notice here when I multiply here, these 3's cancel out, and these 2's cancel out. So really my derivative is just going to be this. And what I want to know is the x value when the slope is negative or less than 0. So here I'm taking the derivative, and instead of making it equal to a number, I want it to be less than 0. I want my x's to be negative, right? All right, so all we're going to do is figure out what x is. So why don't you go ahead and pause this and see if you can't solve this equation. What I might suggest is that you change this. Well, it doesn't make a difference, but you could change this to square root. All right, pause it and solve it, and then start back up again. All right, so hopefully you did that. In this case, I'm probably going to add 2 to both sides. And then I'm going to square both sides. And so I get 2x minus 1 is less than 4. And then I add 1 and divide by 2. And I find out that x is going to be, well, add 1 is going to be 5. And 5 divided by 2. X is going to be less than 2.5. All right? So what I've just found out is the x's, for all the x's less than 2.5, the slopes are going to be negative. So I need a to be 2.5. Now, if it's anything bigger than that, then it could become positive. So I'm assuming that this other part's correct, but all the x's less than 2.5 are going to give me negative slopes. So this is going to be decreasing for that range. And that was worth 4 points right there. Let's take a look. First, you can see finding the derivative. That could be worth 2 points. And then making it less than or equal to 0. I would make it less than since it's got to be negative. And then here you can see, well, we got this here. They're saying that they would allow the equal to 0, but they would not allow greater than 0 because that doesn't make sense in this problem. All right, and then you get the value of a being 2.5. And you can notice that they're okay with any of these coniforms, anything. WW with working. All right, you need to see we can't just have a number. You can't just guess. All right, good. Hopefully that makes sense. Take a look at number 5. We got an equation. Here it is. And they want you to find the derivative and the second derivative. Find the coordinates of each of the stationary points of the curve and determine the nature of each stationary point. All right, pause it and start back up again when you're ready. And then we'll compare. Okay, so hopefully you did that. And here's what I got for my derivatives. Basically, all I'm doing is multiplying by 3. I multiplied by 3, I rewrote this, I lowered the exponent by 1, and then I multiplied by the derivative of the inside, and then I took the derivative of 24x, which is 24. Negative 2 times 3 is negative 6. That's my derivative. Then I take 2 times negative 6 is negative 12, 3 minus 2x, and then I multiply times the derivative of the inside, which again is negative 2, and now the derivative of 24 is 0. So I get negative 2 times negative 12 is 24. That's this, all right? So that's A. And then B, it says find the coordinates of the stationary point, and that means I'm going to make my derivative equal to 0. So 0 equals negative 6, 3 minus 2x squared plus, whoops, let's try that again. 3x squared plus 24. And if I'm doing this, I'm going to subtract 24 on both sides. I'm going to get negative 24 is equal to negative 6. 3 minus squared. And then I'm going to divide by 6, or negative 6 and negative 6. And so when I do that, I'm going to get 4 is equal to 3 minus 2x squared. And then what I'm probably going to do is I'm probably going to square root both sides. Well, actually, you probably shouldn't do that. So let's try this. I didn't do this before. So let's see. 4 equals, this is going to be squared, so it's going to be 9 minus 12x plus 4x squared. And then I'm going to rewrite this so it says 4x squared minus 12x, and I'm going to subtract, so it's going to be plus 5 equals 0. And then what I'm going to do is factor this. So let's see, if I factor it, 4 times 5 is 20, negative 12, divide by 4, divide by 4. Two numbers are multiplied to get to 20 and add to get to 2, so it's going to be negative 10 and negative 2. And so then when I do this, I'm going to get my answers are x is equal to 5 halves, or 2.5, and x is equal to 0.5, okay? Some of you might be thinking that it'd be easier to just square root both sides, And you want to kind of avoid that if you can. I mean, you can't avoid it sometimes. But in this case, it's pretty easy to square a binomial. Anyway, we got our x's, and I look back up here, and it says clearly to give them the coordinates. So what I've got to do now is I've got to substitute in these values here into the original, and it really is just substitution. And when I do that, I get that y is equal to 52. And then when I do that, I get y is equal to 20. So those are my two stationary points. That's part B. And then C, I need to find, determine the nature. And so what I'm going to do then is I'm going to take my second derivative, which happens to be right here, and I'm going to substitute in my two values of 2.5 and here. And so if I do this one, 24, 3 minus 2 times 2.5, I'm going to get negative 48. And then if I do 24 times 3 minus 2 times 0.5, it's going to be positive 48. And so what I've determined then is when x equals 2.5, it's going to be a maximum. And when x equals 0.5, it's going to be a minimum. All right, so that's A, B, C. That's 9 points right there. And, you know, not crazy hard. Now, you know, it's pretty straightforward. I mean, I'm telling you, stationary points is a real common thing. Determine the nature is a real common thing. Let's take a look and see what we got here. So you can get 2 points for getting the derivative. And again, you'll notice that here they're 1 point minus 2. All right, so again, you see this negative 2 here? It's really common when doing the chain rule not to multiply by the derivative of the inside. So what happens is that you can get 1 point for doing that without doing that. All right? And then if you do the derivative correctly, but you do this and you get the other point. All right? So this is a really common error, forgetting about the derivative of the inside. So much for that, that's how they've broken this apart. Doing the derivative with it or without it. And then the second derivative, again, you'll notice that it's the same thing. You can follow through, so if you screwed this up, you can see the second derivative. But again, 1 point, if you don't, you know, if you do this correctly without doing the middle one. All right, so again, that's 4 points right there. And then in part B, find the stationary point, make the derivative equal to 0. That's a method, and you've got to show that and then try to solve it. And again, even if you can't quite get it, you know, actually correct, trying to do that's going to get you a point. Coming up with these answers, x, and you see now, be really clear, because you notice how they ask for coordinates. If you give both x's, then you get 1 point. If you give one pair, then you get 1 point. If you get 2 points, it's because you gave both pairs. So if for some reason you screw up and only give them 1 point, as long as you give them an x or y, you can get 1. But if all you do, notice here, if you give both x's, you get 1 point, or 1 full point, you get 1 point. And you get both points, and you get 2. And then here, in this last one, again, it's pretty straightforward. Follow through. That means if you screwed up the stuff here, as long as you find the second derivative of your derivative, and as long as this stuff makes sense, then you can get these points. And again, in this case, one was a maximum and one was a minimum. Keep in mind, it's positive minimum and negative maximum. All right? And the last one we're going to do, I think, will be this one. Take a look here. This is a weather balloon, And what's happening is that it's in the shape of a sphere. I get asked all the time, what formulas do I need to know? You should know any of the volume formulas that we talked about in Math 3, and that's the volume of a cone, the volume of a cylinder you should be able to find, but you also should be able to find the volume of a sphere. And this problem is kind of reliant on that. In fact, if you don't know find the volume of a sphere, it kind of falls apart really quickly. So any of those volume formulas you are expected to know. Anyway, it says we got this sphere, it's inflated by a pump. The volume of the balloon is increasing at a constant rate of 600 centimeters cubed per cubic centimeters per second. The balloon is empty when we start pumping. All right, so find the radius of the balloon after 30 seconds. Okay, so now think about this. They're telling us that we're pumping in so much air per second, that the size, the volume, is increasing this much per second. So this is really kind of straightforward. What I'm going to do is I'm going to take the 30 seconds and multiply it by 600, and I'm going to find out that it's going to be a volume of 18,000 cubic centimeters. Okay, so find the radius. Now, that's our volume after 30 seconds. And so if I take it and plug that into the formula for volume, volume is equal to 4/3 pi r cubed. If I take this and plug it in, 18,000 is equal to 4/3 pi r cubed. Well, then I should be able to find the radius. So why don't you go ahead and pause this and see if you can't figure out what the radius is based on this, and start back up again when you're ready. Okay, so if you go ahead and just divide both sides, 18,000 by 4/3 pi, and then take the cube root of that number, well, if you divide by 4/3 pi, you should get 4,297.183 blah, 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 blah is equal to r to the third. And see, what I would suggest then is leave this number in your calculator, and then click on your calculator button, the cube root button. You see it's right above the square root button. And then just put answer, and it'll put this whole thing in here. So you're going to type all these digits, but we're going to find out that the radius after 30 seconds is going to be 16.2577 centimeters. All right, so that's part A. Now, find the rate of increase. And so we talked about this. There's a common application problem where they talk about the radius increasing or the x. Keep in mind what happens is we have a function, we've got an input and an output. In this case, the v is the output or the volume, and then this is the input, the r. But at any rate, what happens is one of these two is increasing, and we have to find out how the other one's increasing, okay? And so they want us to find the rate of increase of the radius after 30 seconds. All right, so whenever they're talking about either the radius or, again, it could be x, but something increasing by some kind of rate of time, then you're going to want to use this formula. And in this case, what I'm going to do is it's going to be dv over dt is equal to dv over dr times dr over dt. Notice that these two cancel out, leaving me with dv over dt. This is a true equation, right? And see, what's going to happen is that, and again, it could be like this, dy over dx is equal to, nope, screwed that up. Let's try that again. Dy over dt is equal to dy, what's up with this? dy over dx times dx over dt. All right, so that's all that's happening. It just happens to be in this formula. This by itself is the v, so I'm using this, and then this is on the inside here. Anyway, this is the way I write this. Okay, so what happens is that find the radius, find the rate of increase of the radius after 30 seconds. All right, so after 30 seconds, well, we know that we can find the derivative of this function we've got here, because what they've already done is they've already told us that the volume is increasing at this rate. So I know that this is going to be 600. This is what the volume is increasing. Now, they want me to find this, okay? Now, to do that, I need to get this dv over dr. That's the derivative, right? So what I'm going to do then is I'm going to find the derivative of, here, let's write this down here. Okay, so I've got my volume thing again, right? So volume is equal to 4/3 pi r cubed. Now, if I want to find dv over dr, what I'm going to do is I'm going to multiply 3 times 4/3. That's going to give me 4 pi, and then it won't be r to the third anymore. It's going to be r squared. Okay? So what I'm going to do now is find the rate of increase of the radius after 30 seconds. Well, I know the radius size after 30 seconds because they made me figure that out in part A. So if I plug that in here, that's the radius size. That's going to be 16.2577. All right, that's going to be this number right here. So pause this and figure out what my number is here. And see, then I need to get this by itself. Pause it and start back up again and see if you can figure out the rate that the radius changes in time. Okay, so hopefully you did that. If you plug this in, you should get that the radius, if I plug in this, I should get 3,321.4527. Okay, so when I put that here, 3321.4 blah, 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 blah. All right, now, to get this by itself, I'm going to divide. So it's going to be 600 divided by 331.45727. And that's going to equal the rate changing over time. And when I do that, I get approximately 0.180643, which is going to round to 0.181, 3 significant figures. Okay, so this is a formula that's not on your formula sheet. And when they talk about things changing in a rate of time, then you need to pull it out. And like I said, the pattern of these problems, I mean, actually this is kind of an interesting one, because in the problems in the book, you notice they just kind of say, oh, this is increasing at this time, and then they want to find how the other one's increasing, and they give you some kind of X value. In this case, we had to figure it out. So this is a good problem. Anyway, take a look at the rubric here. Find the volume after 30 seconds, right? And then we know the radius is going to be 16.3, right? Now again, they're saying that, but they're rounding. You don't want to use this rounded number. You don't want to use 16.3. You want to not round in the middle of the problem. At least you're going to go 4 or 5 digits after the decimal point. Okay? So even though they've written 16.3, that's true, but that isn't what number you want to plug into this equation. And see, here they use a slightly different version of this equation, but it ends up being the same thing. I just like mine better because it lines up better. The output, and then there's the in. I mean, this is what I learned how to do, and so. But there's, like if I were to rearrange these, divide and then multiply and get it rearranged, it could be something different. And that's what they're using. But you'll notice you end up doing the same thing. 600 over this number, which we figured out, right? And then we get 0.181 per second, right? And that's good. That's it. All right, hope this helps. Thanks for watching. Have an awesome day.